Okay, all right. Sound test, sound test. Ah, okay. Yep, we're working, we're in. Oh, this is kind of hurting. Good morning. I wonder where can I put this that is not like so on the way. Mm, Let me see. Here. Ah, sound test, sound test, sound. Hey, I'm talking here. All right. I think that looks good. Um, Good morning, everyone. Hey, it's been a while, right? No, it hasn't. It's been only 2 weeks. I've having I'm having like rough weeks with all this pandemic and the teaching and work and stuff. So I'm not being able to keep up with the weekly streaming rhythm these days. But I'm trying to do my best. And I understand. I know you understand uh, that it's complicated times. But I'm back. We're here. How is everyone doing? I'm very happy to see familiar faces. Parastorm, Dusko, Arasto, how you doing, sir? Sujai, welcome back. Andres, so good to see you again. Mm. Let me turn on some lighting here. Wait. Okay. So, all right. Is it better? Yeah. Okay. You should see my my office. It looks like a recording studio. I have so much stuff. I have so many screens, so many lights, so many the green screen, which is even not big enough. Because see, I can't really do, you know, I have to cut it out. Um, but it's okay. Um, Hey, Baba, how are you doing? It's been a while. I hadn't seen you for some time. All right, so um, what are we doing today? Well, first of all, I'm saying hi. We need to remember to be humans in these times of connection and disconnection and remoteness, etc., etc. So spending some time saying hi and acknowledging, uh, yeah, better, and acknowledging our our emotions and our feelings. I think it's a good thing. Also, I just got myself some coffee, so I'm enjoying that. And what are we doing today? So, um, for those of you who might be new to the channel and to the stream, welcome. My name is Jose Luis. I am a designer. I teach technology courses at the design school at Harvard, and I run this show called Parametric Camp, where we do live streams every week, more or less, on computational design. And I touch on topics that have to do with how to be creative using technology, and in particular, very strongly computer code, and very often related to 3D modeling or 3D form generation, just because I have a background in architecture. So I really like 3D environments and 3D geometry, etc., etc. Um, so we do these live streams every Saturday, and I record tutorials. So you will see me doing like, okay, I'm going to start recording. Okay, I'm going to stop recording, because what we do is that we edit them, we trim things out, so we cut them out, and then we publish them as like more polished videos over the course of the week. So that is more or less what we do every week when we can. I'm very happy and very proud to have a wonderful community of people who join me doing this live on Saturdays. And over the course of the weeks and the months, I've been lucky enough to get to know some of you. Also, because we do have a Discord channel. Where is the Discord channel? We do have a Discord channel. Oh, I think I need to copy the invitation. Is that correct? Yes. Invite people. Blah, exactly. We have a Discord channel that we use to keep the conversation going offline every week, and we have some channels where people share work, where people introduce themselves, etc., etc. It's very nice, and for me, it's a very nice way of getting to understand who you are and getting to know your work a little better, and also getting feedback from you. Because also something that I like doing is having a conversation with participants in the chat while I'm streaming, and I get ideas on things, new videos to record. Some people like sometimes like I'm doing something and I'm doing it wrong, and so you call me out and I fix that live, and then we get a better video. I think I'm very happy about that actually. I also maintain this calendar, so I announce pretty much when I'm going to be streaming. I announce it on social media, so we have an Instagram and a Twitter. That's there. Is that there? Yeah, that's there. Those handles. You can follow us on Instagram or Twitter, and I typically post when this is happening. But if you want to make sure that you're always up to date, you can subscribe to this Google Calendar that I just posted on the chat, and I also post there events about when this is going to happen. And for those of you who are not so new to this and you know me already, welcome back. I'm happy to be here and happy to see many of you. And what are we going to do today? Oh, and I forgot, if you're new to this and you want to be up to date and stuff, you're welcome to subscribe and turn on notifications so that you get a message when we're going to go live and when we publish new videos, etc., etc. All those things that you know how YouTube works. What are we going to do today? I have a couple announcements related to Arcadia. Arcadia is the conference on Arcadia is this. I have a couple announcements about that, but also if you've been following our work, what we've been doing in the past few weeks is that I've been working on this playlist called Learning C# for Designers. And it's a playlist where I'm recording a lot of videos on let's learn how to code from scratch. No assumptions. I assume you know absolutely nothing, and I'm going to start from the very, very basics. Variables, simple arithmetic, simple iteration, conditional statements, like everything from scratch. And I chose to use C# as the processing language. Blah, blah, blah. I chose to use C# as the base language because many of the environments that I typically work with, or that people in my field, in the computational design field that we typically work with, accept C# as a language. So it's a very good scripting language for example, if you're working in Grasshopper, if you're working in Dynamo, if you're working in Unity, if you're working on VVVV, all of those accept C# as a scripting language. On top of that, I like C# because it's a strongly typed language, and I believe those languages are really good for learning, as opposed to other languages that are more high level, which are great to work with, like Python and JavaScript. But from an educational standpoint, I believe it's better to start low level and then go higher in abstraction than the other way around. It's a bit more difficult, I believe, but this is a very personal opinion. And also, there's an urban legend out there about people who believe that I hate Python. Um, I'm not going to entirely deny that because I find it a very funny joke, and I like how that people are talking about that. But I don't hate Python. I just have some reservations about it. But it's okay. I'm happy to have constructive criticism and dialogue about your choice of your poor choice of programming languages. Okay. And so we've been working on that playlist. You can check it out on the stream. It's somewhere. Actually, yeah. You can dig down in the main channel, and it's a playlist learning C# for designers. And why? And also interestingly, why is it for designers? I called learning for designers because computer programming is computer programming, and it's for everyone. You don't have to be a designer for that. But it just so happens that I'm giving it a slight angle so that a lot of the examples that I do and a lot of the code that I write to illustrate the concepts somehow relate to design. They relate to drawing things on the screen, or they relate to vector algebra, which is something that is very common in computational design. So that's where the C# for designers is. But honestly, it's a playlist that could be useful for anyone who wants to learn how to write computer code. And also because once I finish that playlist, I will want to start other playlists, where we can focus now on how to use C# as a language in design and computational design environments, such as, for example, Grasshopper, Dynamo, Unity, whatever. Okay, but that will happen at some point in the future. We're not there yet. So all of this to say that the playlist is almost pretty complete. We're right now all the way down. We've done functions, we've done iteration, conditionals, variables, and like we've gotten pretty deep. The only thing that I think it's missing for to complete that initiation to learning C# is object-oriented programming. So, which involves learning about classes, learning about objects, and one of the most important paradigms in computer programming. However, so I need to think yet. I still need to think, how do I want to do that, and what are the exact steps that I want to take? And I haven't done that yet. So I thought, and some people have been complaining or requesting that instead of like always doing C#, that we combine things with other video types that we've been doing before, like for example, geometry gems. So I think today, because I haven't thought through the structure of how I want to teach object-oriented programming, I think today we're going to take a break from learning C# and we're going to go back to geometry gems. And we're going to do a few examples of geometry operations that could be interesting. And I'm going to be just breaking them down. So on my to-do list today is I would like to do a small geometry. You remember we did a gem about removing duplicate points from a list? I would like to do one about removing duplicate lines. So similar principle, but there's like a couple of things that we need to take into account. So I want to do one about that. And I also want to do one about changes of bases. So the idea of like having a coordinate system where we have a point, right? And then what are the coordinates of that point on that coordinate system, and how could we recreate the same point with the same local coordinate systems, but in a different coordinate system? I'm not sure if I said that correctly. But those two should be fairly easy and fast to do. And we have two live streams today. This one and another one starting at 2 p.m. So I'm actually open to suggestions. So if you have like, if you know of like something simple, like a small geometry operation that we haven't taken a look at yet, not something perhaps so involved as Voronoi diagrams or that kind of stuff. But if you have something that you may wanna take a look at, we could probably take a look at. So just post your ideas in the chat and I'll be happy to take a look at them. Otherwise, something that I've been meaning to do is point grids. So the simple idea of using recursion, so using nested for loops to generate grids of points in three-dimensional space, is actually, it's a very simple thing to do, but it's surprisingly not immediate when you are learning how to code and when you're learning computational geometry. So I may just want to do a few examples of like a simple point grid in 2D, like a cylindrical point grid, a spherical point grid, a conical point grid, things like that, right? Or a functional point grid, that could be really interesting too. And that would be an interesting geometry gem leading into using that as the basis for creating meshes, which is also quite interesting. So maybe we could take a look at that. So I think that's going to be the agenda for today. We're going to have some fun. We're going to do some geometry gems. So maybe we can start getting going. I hope to get level 0 C# in Grasshopper. I'm not sure what that means, but if you've been following the other videos, like you're probably like level plus in C#, right? So once we finish that, and then I start a new series like learning C# in Grasshopper, so I can teach you the basics of how to use C# script components, how to enhance them, how to like also go and start creating your own plugins so that you compile them in Visual Studio and you can publish them. That's actually quite interesting. So all right, so let's get going. And also, I want to do a couple announcements. So let me find a couple things here. Arcadia, minimal bounding boxes is a cool topic. Actually, that's not a bad idea. a minimal bounding box on something simple such as a cloud point. That could be interesting. Maybe we could do something like that. Okay, so I'm gonna write that here, minimal bounding box. Minimal bounding box. That's actually not very, if you have a cloud of points, that's actually not very complicated. So, and even if you have a mesh, that's also not very complicated because a mesh literally is a point cloud as well. So yeah. So we're going to do that. Okay, but before I have a couple announcements. So, where are we? Where am I? I don't even know where I am. Okay, I'm here. Alrighty. So, yes, exactly. Oh, why is this? Okay. Am I recording? I am recording. Yes. So I wanted to make a couple announcements. I'm very thankful for the community support. I have been elected as part of the board of directors of the Arcadia Association. Arcadia is the Association for Computer-Aided Design in Architecture. And one of the main events for Arcadia is that we organize a yearly conference where researchers from the world come together and they share their work, we publish papers, and we stay up to date with what people are doing to advance the state of the art in research when it comes to computation applied to computer-aided design. I think it's a really interesting event. It's a really interesting community, and I'm very happy. I'm very proud to have been elected by the community, and I want to give back. So I'm going to be working for 2 years as part of the board of directors and helping bring this community together and helping distribute the knowledge that all the research world is doing. I want my main announcement with this is I want to highlight the fact that many of you might be interested in computation applied to the built environment. This channel, I think of it as design in general, but I understand that many of you might be interested in architecture and the built environment. So I would like to point you to the conference this year. The conference has happened fully online. It did happen throughout this last week, all right? But interestingly, the sponsorship of the event allowed for the first time in history, allowed for all the students who wanted to register to be able to register for free. So if you're a student in any university in the world, you can apply for a registration and then get access to the online platform where all the events and all the recordings have been stored and will be available until November 30th. So even if you missed the conference, you have still the possibility to register and to watch all the recordings from all the sessions. And actually, it's a really interesting, what is the schedule? So you can see that there were like panels on all the possible cool topics in the world throughout the week. Like, I don't know, for example, robotic craft, sensing, automatic fabrication, design culture, AI theory, practice, like all the cool things. So if you're a student, you have free registration. Even if you're not a student, registration this year is fairly affordable. So maybe you want to consider that. And if you do that, even if the conference has passed, all the panels and all the keynotes were recorded. So feel free to go and check it out and perhaps like watch the videos or watch the papers that you might be interested in. And with the registration, if you do, you will get access to the proceedings. So to like PDF copies of all the papers that were published. You will get access to those, I believe, end of the year or beginning of the next one. We're still working on the publication. It's still not ready. It was a strange year. It was a bumpy year. Okay, so you can understand that we're working on that. So yeah, so make sure to check it out if you're interested. And if you are a student, you have free access. And if you're not, it's fairly affordable this year. So just consider if you're interested in checking it out. Okay. All right. So before we move on, I am going to, what am I going to do? I'm going to set up, I'm going to set myself up. Yeah. because we're doing remove duplicate lines first. So where are we with that? Let me check on the chat. Oh, thank you for the congratulations. I was very honored to be elected. Thank you. Okay, so alrighty. So what am I? What am I? Okay, so we need to, first of all, we're going to drop. Oh yeah, because I changed computer, so I don't have bifocals, was it? Okay, so I need to download bifocals. Sorry. Good for Rhino. Good for Rhino, bifocals. All right. Yeah, so this computer, I just got a new computer recently. Also, by the way, you should check the work by Mark Zip. He's a really interesting guy. And this one. Okay, so okay, we're going to save this, and yes. And I don't know where the libraries folder is. I never forget. I always forget. Oh God. Okay, Rhino, Grasshopper folders. I want the components folder. So that's going to be here. So I'm going to drop this here. And do I have to unblock it? Yes, I have to unblock it. Okay, so if I run this now, do I have bifocals? I do not. So maybe it wasn't in the special folders, components folder. Huh. So where did I drop this then? My Grasshopper plugin. Yeah, so this is like an example that I was teaching the other day. So where did I drop this then? Components. I dropped it in clusters. Okay. Okay, libraries. All right, so now I need to restart right now. I'm going to delete this because it's not useful anymore. Telepathy by Mark Zip. I do not know that. Let me look that up. Actually, it's quite interesting. Food for Rhino, telepathy. What is this? Complex definitions can become a mess of wires. How is this different from? How is this different from the just having like what is it called? You know, when you drop something and the wire display is just hidden. How is that different from that? Okay, and then here, what about, yeah, bifocals. Okay, all right. I also, I need to set up, my, my computer for drawing sketches. Okay, so, okay, what a messy day. I'm just not trained on this streaming thing anymore. You see, I need to do it more often. Okay, so I'm going to post this here. And okay, I'm gonna need to. Sorry for making you wait. I was clearly not ready for this today. Okay, in the meantime, I'm going to start creating something that has duplicates. Remove duplicate lines. I'm going to create something that has duplicate lines, and I think that's probably going to be this one here, rectangular. Yes, so if I put a grid of elements here, I get the cells, which I can flatten. And if I flatten them and explode them, I should be getting what? Line-like curve. Okay, so then I can just flatten the result of this. Oop, here. I can just flatten the result of this thing and just get a flat list of redundant curves. Okay. So, alrighty. And I'm going to okay, and I'm going to search for that. Okay, got it. Oops. Oop, my computer is flashing. Okay, so all right, we're there, and now I should be able to have my sketchbook here. There you go. And the layers. Okay, so if I do this, now I can. Okay, oh no, not working. Why is it not working? Oh God. Okay. So what's going on here? Sorry for this. Oh God. Okay. This is the most boring live stream I've done so far. No, here. Okay. Oh, I see. All right. Are we there yet? Okay. So now I should be able. So there you go. Now we're talking. All right. Woo hoo. Hello. Boop. And then smiley facing. All right. I think we're ready. Okay, let's go back to business. All right. We were here. We were creating something that removes duplicate lines. And I'm going to hide this. I'm going to hide this. And we basically have 100 lines in 3D space. And many of them being duplicate. We could actually calculate how many of them are duplicate, but it's not interesting actually. So what I want to do is I want to record a video where we discuss how to write an algorithm that efficiently removes duplicate lines from here. This algorithm is going to assume it's not going to work on a smaller line that is inside of a bigger line. They have to be like perfectly equal, even though they can be flipped. So that's going to be a condition that we're going to do. We're going to use the point comparison that we did when we did remove duplicate points. So let me fetch that file. All right, so files, I wonder where I have that. I'm going to become tutorial file, geometry gems, clean duplicate points. Okay, so that's this one here. And then here in clean duplicate points, we have distance point, distance squared. We're doing by the method of distance. I see. Which is not very, is it fast? It's not very fast. How fast is this? Should we do this? Or should we just compare the, should we just compare the points based on, should we just compare the points based on their coordinates? Interesting. I don't know. I don't know what to do about that. Okay, let's just. I think we want to use the comparison. It's probably faster. It's probably faster. Yes. So we're not going to do the distance between points. We're going to do the comparison between their distance. So that's what we're going to do. That's one thing. And then the other thing will be writing the algorithm. Okay, so let's just start. So I'm going to do some sketches here. Nope. So where are we here? All right. So I'm a little distracted today for some reason. I'm not full 100% here. I don't know why. So what am I going to? Okay, so we have one line. Actually, I can probably do straight lines here. Yeah, one straight line and another straight line. Okay. So that's one thing. Another layer, and then we have the endpoints, right? And then I'm just going to, okay, and then I'm going to here, I'm going to just write 0, 1, 0, 1. And then I'm going to write another one. I'm going to write that this can actually be 0, 1, and 1 and 0, because we want to account for the possibility of them being flipped. It doesn't really have. Yeah, this is actually like a fairly simple algorithm. Anyway, all right. Okay, so let's get started then. I'm going to start with the sketch. Yes. All right, and I'm going to. Okay. All righty. Okay. All right, let's get busy. So before we start, let's obviously, as we typically do, let's think about the algorithm and the rules that we're going to implement here. And I have drawn these two lines. I want you to think of them as being perfectly overlapping, right? So what we're going to do is that the algorithm, we need to find a way to verify that these two lines are the same. This algorithm is going to assume that the endpoints of the line are the same. So we're not going to be looking at the situation where we may have a very long line and we may have like another line on top of it that is perfectly overlapping. This algorithm is not going to be able to do that at this point. We're just going to assume that they're perfectly overlapping, that their endpoints are the same ones. Okay, so one thing that we need to take into consideration is that what we're actually looking at here is the endpoints. So you might be inclined to say, well, one rule that I could find, that I could do to remove these duplicate lines would be, well, maybe I can find the coordinates of the center of those lines, and if it's the same, then it's the same line. But that's actually not, that actually doesn't work, because you could have this line here and this line here might have the same center, but they're not really, well, actually, those two are overlapping. That's a terrible example. But what about this line here and this line here, right? These two lines have the same center, but they're not really overlapping. They're not the same ones. So that's not a good rule. We need to find a rule to remove these lines, and that's going to be that we're going to compare their two endpoints, and if those endpoints are very proximal, they're very close to each other down to a tolerance value that we will specify, then we will remove those lines. But something that we need to keep in mind, and this is very important, is the fact that lines actually do have an internal direction. Okay, so we might be in a situation where the first line have this as the starting point, I'm going to call it 0, and has this as the ending point, I'm going to call this 1. And we might be in a situation where we're lucky and the second line also has this as the first point and has this as the second point. That could be a possibility. However, there might be a case where actually that's not how it works, and because of how those lines have been generated, which polyline they're coming from, or like which algorithm has created them, for some reason they might be overlapping, but they might be overlapping in opposite directions. So this one here might be the first point, and this here must be the second point, could be the second point or the ending point of that line. So we also want this algorithm to account for the fact that we want to remove duplicate lines that might be flipped against each other. Okay, so we're going to have to take that into consideration, and that's part of what we will do as we write the algorithm. Okay, and then the only thing that we also need to keep into consideration is a similar thing to what we did when we did the remove duplicate points algorithm. When we search the list, so imagine we have, this is a list of lines. This is not lines. This is just a list of objects, right? Something that we need to keep in mind is that when we search through the list of all lines and we want to see if this line has a duplicate in the line, in the list, what we will want to do is we will want to go backwards and start searching from the last one, the second to last one, the third to last one, etc. Because if at some point, if at any point we remove one line from the list because it's duplicate, remember that these two lines will stack up. They will get one index number less, and therefore the list will change in size. So if we were searching this way and we remove the line, the rest of the lines remaining will change in index number, and it's a bit more tedious. So it's typically very good practice when you are searching a list that you want to remove elements from, to start from the end and remove elements backwards. Remove from the end to the beginning, because index numbers don't really change in that situation. If you want to learn more about that, please check my previous video on removing duplicate points, where I explain why we're doing that and the techniques involved in that. All right. So let's get busy and oh, sorry, I was in the middle of the drawing. So let's get busy and let's start implementing this. Let's start implementing this. All right. Okay, so we have this. So what are we going to do? We're going to we are going to, am I going to write the component here? Yes, I'm going to create, let's speed this up. So this is going to be in lines, this is going to be clean lines, and this is going to be tolerance. Alrighty. So this is going to be here. This is going to be tolerance is going to be what? A value that we're going to specify here. And then clean lines is going to be something that we're going to be working on. Not working. And then another panel here and another panel here. Well, actually, that is not going to tell us really much. So, this one has 100 elements. This one is going to have this many elements. Okay, so I think I'm going to start with that. I'm going to group this here. Oh no. Why pink? Oh, why do I have pink here? Saturation, hue, value. Okay. All right, I like that better. You know me already. I'm kind of a minimalist when it comes to color. Okay, make default color and then group things here. Yeah, I'm a little off today. I don't know what's wrong with me. Okay. All right, so I think I'm going to start here and I'm going to transition to the other side of the sketch, and then I'm going to be writing code here. Alrighty, so let's start. What I've done here is I have created a very simple algorithm where I have created a grid of rectangles, so a grid of squares. Okay, I have exploded all those squares, and then I have flattened that list. I'm exploding these squares because, as you can see, if I have one square here and I have another square here, this line is going to be duplicate when I explode them together. This line is going to be duplicate between the two cells. This line is going to be duplicate. So this arrangement here will actually have a lot of duplicate lines, except they will all be duplicate lines except for the ones at the boundaries. Okay, so if I explode them, I would get a tree-like structure that has 4 lines for each one of the squares, right? However, I am flattening that list because I want to end up with one list that contains all the elements on the same list so that I can start looking at them and removing the duplicate ones. Okay? And then what I have done is I have gone here and I have created a C# script that is going to take that list of lines, is going to take a tolerance value for comparing the endpoints. I'm going to talk about that in a second. And then it's going to spit out a similar list of lines, but which is going to be clean. It's going to have all those duplicates removed. So we need to remember first to properly type the inputs of the C# component. So in this case, lines will be, for example, the type of the input will be of the type hint here and will be of the type line, okay? And something that is very important is because in this case, I want to take the whole list of elements so that I can compare them together with each other. Then in this case, item access is not going to be good because I don't want the component to work with each one of the lines individually. I want the component to work with the whole list of lines together. So I need to double click here and set the access level to list. Similarly for tolerance, I'm just going to choose a double value here. So I'm not sure why. Oh, so I'm just going to choose a double value here. Oh, and it's popping out on my other screen. So all right, so tolerance, where is double? Double. All right. Okay, and then as I double click here, you can see that my component now is taking an input of line objects, a list of line objects called lines, and then a double, which is the tolerance value for the comparison, okay? And then what we're going to do now is we're going to write an algorithm that is going to go over each one of the lines one by one. It's going to compare that line to the rest of the lines. For each one of those comparisons, it's going to look at the endpoints, both the first one with the first one and the second one with the second one, or it's going to look at the first one with the second one and the second one with the first one. And if they are the same, then it will remove that list. It will remove that line from the list. Okay? Let's take a look at how we would implement that. All right, I need to take a second. I'll be right back. Stay there. Don't go anywhere. I'll be right back. Okay. I'm actually thinking that I may want to start with a simpler example and then just take two lines that are um, two lines that are um, two lines that are overlapping, and then just write how they will overlap. So just write that algorithm first, and then just do like the whole list thing. I think I'm going to do that actually. So let's make actually line A. This is going to be item. The second one is going to be, and then that's going to be a line. The second one is also going to be a line. This one, I'm going to call this line B. R duplicate. And then should I do this live? Maybe I should do this live. Okay. So disconnect here. Disconnect. Okay, let's do this. Actually, I just had an idea, and I think it's going to be better that we first hone down on the simple case of having two lines and comparing them if they're duplicate. So let's do that first, and let's explain how that works. And then we can expand that into just taking a full list of elements and comparing them and doing like the whole comparison between the whole list, okay? So what I'm going to do is I'm going to create a simple line here, okay? I'm going to bring it into Grasshopper by setting this, okay, so I'm just going to bring it in as a curve. So I'm going to set this curve, right? And then I'm going to use that as a duplicate. But also I'm going to create a second one. So that's going to go from the other end to the other end. Okay. So I'm going to bring that in as well. by setting set one curve and then just setting the second one that I just created here. And then let's see if I actually chose the right ones. So if I say endpoints and I take this one here, then I should have the start points and the end points. Okay. And then if I compare with the other one, yes. So you can see that both lines have the same start point and the end points. They're just flipped. Okay. So that's going to be a good two lines to be compared. And then here, I just wrote a small component that takes line A and line B and compares them if they are duplicate. Okay. So also we may also want to just add a third line, which is not a duplicate one, to make sure that the algorithm works well. So I'm going to set this one here, okay? And this is going to be the one that is not a duplicate. These two are duplicates, but this one is not. So here I'm going to choose line as the input data. Here I'm also going to choose line as the input data. And first of all, I'm going to try with the same line twice, okay? And then here the component is going to tell us if these two lines are duplicate or not. All right? Okay, so let's give it a try. So here I'm going to write the code to compare these two lines if they're together. And if you know me already, you know that I like building code that is reusable. So basically here in the main script, I'm almost just not going to write anything. What I'm going to do is I'm going to write a function here that given two lines returns true or false if they are duplicate. Okay, and then in the main component, I'll just call that function. I do that because then I really like copying and pasting code between my components and my functions. So if I create a function that does that, it will be much easier to reuse in other places. Okay. So I'm going to create a function here and I'm going to call rduplicate. And then this is going to take a line object called A. And then it's going to take another line object called B. And it's going to return a Boolean value whether if these two objects are duplicate or not. All right. And then, so for the time being, I'm just going to say return false. Because I'm just going to write placeholder code and I want to make sure that everything works. So this is working right now. And then here, what I would do is I would write a Boolean variable dup, and this is going to be equal to the result of saying, are these two lines duplicate, and passing line A and line B. And then, and actually, you know what? Actually, I could just do here, I could just do duplicate. Sorry. I could just pass this directly to the outcome, duplicate to the output directly like this. Oh, I'm really... Okay, so the output is this component. The duplicate is going to be the result of calling this function that is going to take line A and line B, what comes as an input, and it's going to call this function and it's going to return the outcome, which is that Boolean variable. Now, okay, so now let's write some code to make sure that line A and line B are the same. So we said that what we're going to do is compare starting points, and then if they're not, then compare, if they're not the same, compare start plus end points. So we're going to compare them cross. And if that is not true, then we will not, and if those are not equal, then this line will not be a duplicate. So what can we do for that? Well, so a typical thing that a typical tendency could be to say, well, how can we compare these 2 points if they're equal? Can I do the following? Can I say if the line A, if the start point, which is called from, equals b dot from, then these 2 elements must be the same. All right. However, that is actually not a good technique to use, because in computer programming, when you compare objects like this, you're typically not comparing their XYZ values. The computer doesn't really know that points, like for example from, the computer doesn't really know that they have XYZ points, XYZ coordinates, and that equality between those 2 objects means that XYZ coordinates should be very similar, okay? So that's not how it works. What we need to do is we need to manually check that their coordinates are actually, their XYZ points are actually very similar or equal, okay? So what I'm going to do now then is I'm going to create another function that is going to be called RDuplicate, and this is very interesting. RDuplicate, or I'm going to call it RSimilar, all right? And what this function is going to do is going to take a point 3D A and another point 3D B, and then it's going to return true or false whether if those two values, those 2 points have similar coordinates, all right? And I'm saying similar because our here returns true if coordinates of points are equal. All right. A tendency for us would be, let's create a variable and say, are these guys similar? And then what we do here is we compare the XYZ coordinates. And we could say, my way for comparing them is going to be a dot x is the coordinate x equal to the coordinate x of b, and is the coordinate y equal to the other coordinate y, all right, and is a dot c equals to b dot c. So, and I'm going to just write a parenthesis. We don't really need this parenthesis, but it's just a little better visually to understand what I just wrote here. So our tendency could say, well, we can just compare the values of x and x for the 2 points and the values of y and y for the 2 points and the values of z and c, and see if they're equal. And if they're not, then we return true or we return false. However, this is not really a good technique either, because it happens that due to the nature of floating point numbers or double numbers, it turns out that we can't really compare numbers that have a decimal part with a straight equal sign, because depending on where those numbers are coming from, they may actually have like very, very small differences in the precision in their decimal part, and the computer will have a really hard time comparing them. And it may actually happen that two numbers that for us, they look identical, even to their whole precision, all the decimal numbers, their internal representation as a double may actually not be exactly the same. And we may just have points that are actually very, very close to each other, but if we compare them with the equal symbol, it will return false, okay? So actually, what we typically do is that instead of comparing whether if these two values are equal, what we do is we compare the distance between them, and if that distance is below a particular threshold that we typically call tolerance, then those numbers, we assume that they are the same, all right? So we don't really compare for equality. So what we do is we compare for similarity. If those two values are close enough to each other under a particular threshold. So how will we go about that? Well, first of all, let me add a third parameter here that I'm going to call tolerance. All right, and tolerance, and then I'm going to set that it has to be a double. Okay, and then I'm just going to plug this in here. Now I have here my tolerance, and then I'm going to pass this to the function tolerance. I'm going to compare lines based on a tolerance value, and then here I'm going to compare tolerance or D, whatever. And then let's say that this function takes a value that is called tolerance, for example. All right. The way to compare this would be the following. What I would do is I would say, are these points similar? And what I'm going to add here is the result of, first of all, I'm going to subtract the coordinate x minus the coordinate x of the other point. I'm going to subtract those two. and I want to know how far away they are. But before I do that, I need to make sure that the value that I compare is not the actual subtraction, is the absolute value of that subtraction. Because it turns out that if A is slightly bigger than B, we get a positive number. But if B is slightly bigger than A, then we will get a negative number. And therefore, the comparison will not be great. So what we want to do is we want to take the absolute value of this difference so that we know that this value is always going to be positive. And then see if this value is less than the tolerance that, that we have specified. So if the absolute value of their difference is less than tolerance, and I'm going to copy and paste the same thing for y in this case, so that's going to be y. My God, this is going to be y, and then if this is going to be and, if this is going to be c, and if this is going to be c, if these three conditions apply, if the x coordinates are less than a tolerance, and if the y coordinates are subtracted are less than the tolerance, and these are less than the tolerance, then this whole thing will be true, and therefore the 2 points will be similar. Otherwise, they will be false. If one of these fails, then this whole expression will be false. And then here I can return similar. Okay? So this is actually a fairly cheap way of comparing points, but it's also a fairly good one because we don't have problems with precision. We can control what for us duplicate means, how far away the ends must be, and then yeah, it's a very common way of doing it, basically. All right, so let's actually make sure that this works well. First of all, so I'm going to cancel this out, and I'm going to cancel this out for the time being. And here, just for the sake of experimenting, I'm going to say duplicate is going to be equal to, are these points similar? And then I'm going to take from the starting point of line A, I'm going to take the starting point of line B, and I'm going to take tolerance. I'm going to pass tolerance as the value. I'm going to run this, okay? And we can see that indeed, for the same curve that has been passed to these two, both the starting points of those two lines are the same, okay? And even if I reduce the tolerance value, you see, when it goes back to 0, it's not working, but if I make it a very small value, it works. Now, if I were to plug in this curve here, right, the one that is totally off, this should be changed to false, okay, because the starting points are not the same. And if I were to plug in the one that is the same but inversed, so the same but in a different direction, it should give me false as well because the starting points are not the same. The starting point and the end point of them are the same, okay? All right, so it looks like our similarity comparison for points is working. So that's good, all right? Now, let's use this to compare the two lines here. So I'm going to say, remember what we discussed? We are going, I don't know what I've done. Sorry. So remember what we said. We're going to compare the two lines and we're going to say these lines are going to be duplicate if both the starting points and the end points are the same, or if the start point and the end point of one and the end point and the start point of the other one are the same. Otherwise, they're going to be different. So how can we do that? So we can say, first of all, let me compare things. If the starting point of the two are the same, okay? If the starting point is the same, and the endpoints of the two are the same, so 2 and 2, if these two are the same, Okay, I'm actually going to write it in the same line. I'm actually going to write it here. If these two and are the same, I'm making a mess here. If this is true, okay, so if the starting points both are under the same tolerance and the endpoints are both under the same tolerance, okay, or I'm going to compare the opposites. So I'm going to say if the starting point of line A equals the end point of line B and the end point of line A equals the starting point of line B, all right? If these two things are true, then I want my function to return the value of true. Otherwise, if they are not, I want to return the value of false. Okay, this can be written in multiple ways, and I think I have a problem with the curly brackets. I think I'm putting way too many curly brackets somewhere. Yes, I'm missing these curly brackets here, and then here, here, this one. Yeah, I'm missing another set of I'm missing, yes, here. Okay, and I'm still getting an error. What is going on here? Line A and line B doesn't exist. Oh yeah, sorry, because this is A and this is A and this is A and this is A and this is B and this is B and this is B and this is B. Okay. And then tolerance. Okay, so I'm just going to rename. So this is going to be line A. This is going to be line B, and this is going to be tolerance. It doesn't really matter. Okay. All right. So, and then the output is going to be this one. Okay. So let's see if this works. So we're going to compare the one line against itself. So this should be true, which it is at this point. All right. Now I'm going to compare this line with the same one that was flipped. This should be true, and it is identically, it is true. And I'm going to compare the one line with a line that is totally somewhere else. So that's going to be somewhere here. And this one is false. Okay. All right. So it looks like our algorithm to compare two lines if they are duplicate is working right now. All right, so now let's see how can we take this code and then how can we take a full list of lines and compare them with each other and then remove the duplicates. Let's take a look at how that works. All right, I am not very... You see, this is what happens when you skip a week. You lose fluidity. I'm making a big mess today. I'm definitely not feeling it completely. All right, so we have this returns true if coordinates of points are, and I have all these typos. I can't even type today. Coordinates of points are similar under a threshold value. Returns true if what just happened here? Returns true if end points of lines are similar under tolerance value. Okay, so I'm going to copy and paste this. I'm going to copy and paste this, and I'm going to paste it here. And this is what we're going to work with. Okay. Oh, what a day. Okay. compare two single lines, and then compare a list of lines. Okay, so now we're going to go back to this component and we're going to write an algorithm that that goes over a list of lines and removes the ones that are duplicate. And in order to do that, I'm just going to create a function. The function is going to iterate over all the lines. Maybe I should draw a diagram for that. Maybe I could draw a diagram for that. Yes. So I'm going to draw a diagram. And 1, 2, 3, 4, 5, 6, 7, 8, whatever. Okay. It's going to be 0, 1, 2, 3, 4, 5, 6, 7. Okay. Okay, so let's go back to where we were before. I'm going to go back to the component where I was going to write my algorithms to remove the duplicate lines. I'm going to double click and you can see that I have already copy pasted the functions that I created for my simple case of comparing two lines, okay, because I will use that function when comparing all the lines together. And as I said before, I like writing reusable code. So I'm going to write, instead of writing the algorithm for comparisons here, I'm just going to wrap it into a function so that I can move it and paste it between other components, just like I did with these ones here. Okay, so what I'm going to do is I want a function that, given a list of lines and a tolerance value, returns another list of lines without the duplicate ones. So therefore, the return type is going to be a list of line objects, right? And then I'm going to call this function, for example, remove duplicates. This is going to take a list of line objects called, for example, lines. And the fact that these lines and these lines have the same name is purely coincidental. It doesn't really matter. And then I'm going to also pass in a tolerance value. Okay. So how are we going to write this algorithm? Well, first of all, I probably want to create a list of lines, an empty list of lines that I'm going to call clean. And I'm going to initialize it to a new list of line objects that is going to be empty. All right. And then what I would like to do is I would like to take these lines and I would like to iterate over all of them, compare them together, and those that are duplicate get removed from the list. If you remember from my previous video in which I was removing duplicate points, I explained how the way we're going to do this is by looking at each one of the lines, each one of the objects in order. So I'm going to start with the first one. I'm going to start with this first one, and then I'm going to compare it with the last one and the second one and the third, this one. I'm going to compare them in order backwards. And if I find one that needs to be removed, then all the elements will reorder in numbers, but that will not affect how I keep checking the next one, the next one, and the next one. And the second one that I will choose will be, okay, now I'm going to compare this one, and I'm going to compare it against this one, this one, this one, this one. So I'm going to always start one by one and compare against the rest of the list backwards. All right. If you want to know more about why this has an advantage, please check my other video. All right. So we're going to do that. So what I'm going to do is, first of all, I'm going to create a for loop that goes over all the lines on the list. So for int I equals 0, I is less than the number of lists in the lines. So lines dot count, and then I plus plus, and then for this one I'm going to take the line that I'm going to compare. So this is going to be lines. I'm going to take this one. All right. So now what I would like to do is I would like to compare all of these against all the other ones. And actually, now that I'm thinking about this, instead of starting with an empty line here, what I would like to do is, instead of starting with an empty clean list here, what I would like to do is I would like to start by copying this other list here. Okay, and I can't really do that. Okay, give me a second here. Okay. So, what am I missing here? I don't want to start with an empty list. I want to start with a list that has all the elements in it. And how do I copy a list? I forget. I've done this before and I forget. C# list copy. Yeah, I forget how do I do clone a generic list. Yeah. Oh God. Okay. So maybe I should just iterate over the whole thing and dump all the lines, because the thing is, I don't want to. So I don't want to start with an empty list. I want to start with a list that has a copy of all the lines and then start removing them. But I don't want to do that with this object, the one that is given to the function, because if I do it there, I'm actually changing the input list because it gets passed by reference, not by value. And even though in Grasshopper, this doesn't matter because all the objects are already passed by value when they come into the component, it's really not good practice. If I were to copy this somewhere else, I would actually be affecting the original line list. I would not be returning a new line list. So I think the best way to do this would be to first copy the whole list manually, I guess, and then just cleaning it, which is not a very optimal process, but it's fine. So let's just do that. Yes, so before we start doing anything, I actually, instead of starting from a clean line, instead of starting from a clean list, what I would like to do is I would like to start from a copy of the original list of lines that has been given to the function. So create a copy with all those lines and start removing them. I want to do that because it's typically not good practice to actually change the inputs that are coming into your function. And because this is a list of lines, this object, the list of lines, will be passed by referenced. So if I change it inside of my function, it will also be changed in the original source code that is calling that function. And that is typically not considered good practice unless it's purposefully what you want to do. In Grasshopper world, it doesn't really matter because Grasshopper works with references and values a little different, and anything that comes into a component is already passed as a copy anyway. But it's typically not good practice. So I wouldn't want, if we were to copy this code somewhere else, it may actually affect the source, and that's something that we don't want to do. So what I'm going to do is I'm just going to manually use a for loop to copy all these lines one by one and to copy them into the clean list. So I'm going to start with a list that is a pure copy of the original list, and then I'm going to start cleaning them out. So I'm just going to write copy original list. So I'm going to say for int I equals 0, I is less than lines.count, and then I plus plus. I'm just going to the clean list, I'm going to add a copy to the original lines. I'm going to run this, and it looks like I'm getting an error. Yes, I'm getting an error because I am not returning anything from this function yet. So I'm just going to, as a placeholder, I'm just going to return the clean list right now. Okay. All right. And then the next thing that I'm going to do is I'm going to clean up the list of duplicates. And that's what I was doing before. So I'm going to say, first of all, I'm going to create a for loop that goes over all the elements on the list. Remember, I'm going to start with the first one, the second one, and third one, and compare them against the rest of the ones on the list. So I'm going to say for int I equals 0, I is going to be less than, in this case, it's going to be the amount of elements on the clean list, because as that list starts getting less and less elements, we need to account for those elements being removed. So I'm going to say, let me first take whichever line I want to compare. So that's going to be from the clean list. It's going to be the one, the first one, the second one, the third one, whatever. And then what I want to do is I want to compare that one. I want to compare that one against all the other ones that are on the list, but starting from the back. Okay. So what I'm going to do is I'm going to create here another nested for loop for int j equals however many elements are on the list minus 1. All right, so it's going to start by the last element of the list, remember? And that's going to be how much elements we have? Minus 1. All right, then I'm going to say j has to be greater than 0. Not in this case. J has to be greater than the number of the list, the number that of the line that we are comparing. Okay, so for example, if we are comparing line number, if we're comparing line number 2 with all the other ones, then j, when we go backwards, has to be greater than the value of 2. If that doesn't work, then then we're done comparing. So j has to be greater than I, and then j has to go backwards. So instead of increasing, has to go minus minus. And then what we're going to do here is then we're going to take, I'm going to take the other one and I'm going to say that's going to be j. That's going to be the line that is in j. Okay. So what I'm going to do now is I'm going to say dup, and I'm going to store the result of r duplicate, and I'm going to call this function with the first line, all right, the second line, and the tolerance value. So what I'm doing here is I'm taking the line that I'm comparing, and I'm taking the other line that I'm comparing, and then I'm checking if they are duplicate with the tolerance value that has been given to this function. And if they are duplicate, if dup equals true, then what I need to do is I need to remove from the clean lines, I need to remove this element here. So how do I do that? I just type clean and then remove at. So remove whichever element is at position with an index number. And I know that the index number of the other line that I want to check is going to be j. All right. So I want to remove from that list, I want to remove a j, the object that is at position j. And I think that's actually pretty much it, because like I'm going to keep checking with this for loop. I keep checking more and more lines. This algorithm will work for if I have like many lines that are duplicate. And here I just keep checking one by one. And as this list decreases in elements, it has less and less, then I will approach the end of the line, and then whatever that is, we're basically good to go. So let me see if that works. So I should be, oh yeah, well, I haven't really called that function. So let me say clean lines should be equal to remove duplicates. All right. And then lines and then tolerance. And then let's see if that works. Oh, all right. So it looks like in the original list, I had 100 elements. And on this list, I have 59 elements. So it looks like I have removed basically, how many? How many is that? Sorry, 60 elements. I have removed 40 elements. Okay, that sounds about right to me. I'm not sure what could we do to compare this, but it works. But it works well. Okay. All right, Victor, what's going on there? We're expanding this to curves. We're doing just lines for the time being, because like curves is a completely different animal. I don't think the clean. I don't think that way of copying works. I tried it before, and it wouldn't let me. Would this work instead of iterating through the list? I don't think it works. I just tried that, and it didn't. Um, you know what? It may work. Maybe this what list line clean 2 equals new list of line. I wonder if this works. Lines. Nope, doesn't work. Can I convert from to? Oh, no, this has to be a single line. And this doesn't work. I tried it before. What? I tried it before. That is so strange. Huh. But I did try that. What did I do? That gave me an error. Oh, I was probably this other error. Hmm. The error was here instead of here. Oh my god, this is what a day. Okay, then I can probably just talk about that right now. um, uh, yeah, I can probably talk a little bit about that. Okay. Okay, one quick thing we have discovered is that before, when I was trying to copy the list by passing lines here, I thought I couldn't do this because I was getting an error, but it turns out that the error was coming from somewhere else, and it turns out that this is a valid way of copying the list. So instead of having to iterate through the list, I can actually just copy it by when I create the new list, passing in another list to create a shallow copy of that list. So actually this code works, and it's easier and faster than having to iterate manually with a for loop over the two lists and copy one and copy the other. Okay. All right, and I need to wrap up this video. I wonder how can we check if this is working well, because like there should be. I wonder if we can compare this with some grasshopper. Remove duplicate lines. Huh. Okay, so if I do this, I get 60 lines. So if I compare with the kangaroo component, I also get 60 lines. That's kind of encouraging. It means that it's probably okay. All right. So I don't know how can we compare that. Um, so I guess we're just gonna leave it there. Okay, so let me wrap up the exercise. I'm also noticing that my head here on the right-hand side is not great for grasshopper. This is coming from the teaching from the C sharp from the C sharp videos. Anyway, oh, I'm having a rough morning today. What is going on? Okay, let's just wrap this up. Okay. Okay, so I think with this, we're ready to wrap this up. So we have written an algorithm to remove duplicate lines under the condition that we were checking the endpoints. So this is going to work for lines that have similar endpoints, but perhaps not for lines that are only partially overlapping. Okay, that would be a different algorithm. So with this, we're in. So if you like what you saw, please remember to subscribe, check notifications for more videos on geometry gems, computational design, learning how to code, etc., etc. Thank you very much. Very good, Arasto. I need to record the introduction. You are right, because I always forget. Okay. All right. Hi, and welcome to another geometry gem, where in this one, what we're going to do is we're going to write a very simple algorithm to take a list of lines and then remove the ones that are duplicate. This is a very common scenario, for example, when we have geometry that is overlapping. So imagine this grid of rectangles, and if we were to explode all those rectangles into their individual lines, we will see that this line here is duplicated because it was coming from two different rectangles. This line here is duplicated, it's coming from two different rectangles, etc. So if we wanted a cleaner list of lines, we would actually have to go through the whole thing, compare them together, and remove the ones that are duplicate. So that's what we're going to do in this exercise. It's going to be very simple. The condition for this removal is going to be that we're going to compare the endpoints, all right? And we're going to see if those are similar. And for those situations where they are, we will be removing the duplicate line. This will not work. This will be a different algorithm than, for example, checking if a longer line is overlapping a shorter line on top of it, where their endpoints don't really match, even though they're overlapping and they're duplicate in a way. That is a different case, and which we're not going to treat here. And we're going to see that in this example, I'm going to first write how two lines combined can be compared in the simple case. And then I'm going to write another component that is going to take the whole list and it's going to do the cleaning process. Okay. This is going to be very similar to a previous geometry gem that we've done before, where we were removing duplicate points from a whole list. And we're going to base ourselves, some of the techniques that we're going to use here are going to be based on what we learned on that geometry gem. So I encourage you to check that one out as well. Let's get into it. Alrighty. Okay. Sherman, I haven't watched the remove duplicate points. Can we use a hash set for removing duplicate points? A hash set is good for removing duplicate objects that have the same signature. What that means is that if they were created, let me actually, to remove duplicate objects that have the same signature. So if the object is actually the same, all right, if it was created under the same class and it was just created once, then hash set, the way it works is that it already tells you that you cannot store the same object two times. But the problem with points is that you can actually manually create the same point over and over again with the same XYZ coordinates. But if you do it like multiple times, you can create, for example, 10 copies of the same object, of the same point that has the same XYZ coordinates, but they will still be different objects. It's like having different clones of the same XYZ values. So because they are different objects that are stored in different places of the memory and have different hash values, then the hash set will not remove them, even though they have the same XYZ coordinates. So that's why for us, when it comes to geometry, we actually have to look at those coordinates and compare them to make sure that they're the same or they're different. So I don't think hash set would work in this case. What would be the best way to find duplicates if the second line is shorter but completely overlaps? Well, one way of doing that could be to take the two ends of the line and find its explicit equation, all right? Sorry, its implicit equation, and then with the values of the slope and the values of where it intersects with the YC plane, then use those values to compare if the two lines are the same. Okay, if they have like the same orientation in 3D space, etc. And then once you have that, then you can look at the endpoints and see if they overlap, they don't overlap, etc., etc. So in that situation, I would use the implicit equation, which we could do, I guess. That could be an interesting exercise because it will also be an interesting exercise of translating between explicit and implicit equations for the line, which is also kind of interesting. Yeah. And I think I need a break. I'm not doing a good job this morning for some reason. I'm a little fuzzy. So I think we're going to stop it here. And then I'm probably going to record another gem in the afternoon. So I can see you there in the afternoon. If there's any other questions, I'm happy to take them now. Otherwise, I can see you later at 2 p.m. How about that? How does that sound? All right, wonderful. So I guess I'll see you later in the afternoon. Have a good one. See you at 2 p.m. if you want any more of this. Bye.